Alright, ladies and gentlemen, in this video we are going to prove the alternate interior angles theorem. So we're going to actually prove the entire theorem that if two lines are cut by a parallel, then the pairs of alternate interior angles are congruent. So this is just a basic statement for the theorem, so let's kind of give a given and a prove statement of our particular situation that we have. So what we're saying here now is that we are given that in this case P is parallel to Q, and that means that our goal is to prove that a pair of alternate interior angles are congruent. So that means angle 1 is congruent to angle 2. That's what we're trying to prove here in the end. Alright, so remember, because this is the proof of the alternate interior angles congruency theorem, you cannot use that in its own proof. So let's kind of think of some other ways that we can use. So let's start first and foremost that we know that P is parallel to Q. So P is parallel to Q, that is given to us. Well, what do we know about the problem? So let's take a look at this diagram here for a sec. Remember, we only know at this point in time, we haven't proven anything past the corresponding angles theorem. So we can't necessarily use alternate exterior angles. We can't use consecutive interior angles. We have to use only so far what is proven in our curriculum. And so far, all we have proven is the corresponding angles theorem. So we have to keep that in mind as we continue to go forward. So what do I notice? Well, I notice right here that I have vertical angles. And my number 1 and number 2 look-fors for our any type of proof, all right? We'll talk more about reflexive property a little bit later. My number 1 look-for is reflexive property. Are any sides shared? And then my number 2 look-for is to look for vertical angles. Always look for vertical angles because it's the easiest thing that you can do to prove that two angles are congruent. And so let's utilize the fact that angle 2 is congruent to angle 3 by the vertical angles congruency theorem. Okay, but I want to show that 1 is congruent to 2. But take a look. What is angle 1 and angle 3? Well, angle 1 is congruent to angle 3 because they are corresponding angles. So corresponding angles theorem. Well, if 3 is congruent to 2 and 3 is congruent to 1, that means that we're basically saying that 1 and 2 are also going to be congruent, right? If A equals B, and I should say go the other way around, if A equals B and B equals C, then A equals C as well. And so then we can say that angle 1 is congruent to angle 2 by our transitive property of congruency. And I have congruency because we have congruencies and not equal signs.